We will now start our work on Chapter 8, which is on areas. And some of these areas will be familiar to you, particularly the first page here with the rectangles, and maybe as we get into triangles, these would be areas that you probably have worked with and maybe formulas that you have worked with. So hopefully a little bit of overlap with your previous knowledge, and then we'll introduce some new work. But also take a look at where these formulas come from. So it's not just about using the formula. It is about seeing why that formula is what it is. So the area of a plane figure is the measure of the region enclosed by the figure. When you're looking at the area, you're talking about the space that is inside of the figure. And that enclosed space is made up of little tiny squares. Now actually they don't have to be little tiny squares, they can just be the same square, whether they are small or large. They might be squares with centimeters on each side, or squares with a foot on each side, or squares with millimeters on each side. So you can have squares of any size, but in the end we're trying to figure out how many squares fit inside of the entire shape, and then that will be our answer for the area. When we're looking at rectangles, in this unit we're going to refer to one side of the rectangle as the base, and the other side of the rectangle as the height. The height is always perpendicular to the base. They always have a 90-degree angle between them. You may have seen the same rectangle referred to with its length and the width, but we're going to use base and height for the terms on the two sides of the rectangle. So the rectangle area conjecture is the area of a rectangle, and it's given by the formula area is equal to the base length times the height measure. So the base length and the height length, where capital A is the area and B is the length of the base and H is the height of the rectangle. Typically we are going to use a capital letter to represent the areas and lowercase letters to use to refer to the lengths between two sides. So capital letter usually refers to an area. So area is base times height. Like I said, this is probably one of those formulas you have seen before, but we are going to continue our use with the 4 steps so we can stay consistent, and so we're able to show our work and be able to see where our mistakes might be if we make mistakes. So area is equal to base times height. In this first example, that means the area is equal to 12 times 8. 12 times 8 is 96. So remember we say steps 3 and 4 sometimes combine together. Basically, you are just doing the rest of the work, and then step 4 is showing your final answer, so 96. So then the next question is, what is the unit that we should use for area? Remember we talked about the area is made up of little tiny squares. So when we refer to the area, we are referring to literally the squares, and we might call them square inches, or we might call them square centimeters, which gets a little long to write out. So we come up with abbreviations for these, and inches you might know is IN, so IN, and the square part is like there is a little exponent of 2, so this square inches would be that unit. Square centimeters, cm, is our abbreviation for centimeters, and we use a little exponent of 2 next to the unit to represent square centimeters. Because really what we're doing is we're multiplying a certain number of centimeters on the base times the certain number of centimeters on the height. So centimeters times centimeters gets multiplied and becomes square centimeters. So back down in our problem here, we have 96, and then since feet are being used, 12 feet times 8 feet would be 96 square feet. So our final answer is 96 square feet. So the feet are made up of little squares, or the area is made up of little squares, and the squares would have 1 foot on each side. So 96 of those would fit inside of the 8 by 12 rectangle. Example number 2 is the same idea. We have area is equal to base times the height. So the area is equal to 2.3 times 4.5. Sometimes you can use parentheses to represent the multiplication there. So I'll just do this problem with those parentheses there. So 2.3 times 4.5, that would be one you might need to punch in on your calculator. But that comes out to 10.35. And again, since this is an area, we need the area unit. So that would be square centimeters this time. 2.3 centimeters times 4.5 centimeters. Centimeters times centimeters would give you square centimeters. So 10.35 square centimeters is our answer. Example number 3 is like some of the problems that we have done now where we need to work our way backwards, kind of like in the last unit with arc length, and you had to solve for, say, the radius or the diameter. In this case, we are going to be given the area, and we are going to have to find the base. So area is equal to base times height. Step 2, plug in your numbers. So in this case, we have 168 is our area, 168 square feet. And then we have our height, but we don't have our base. So base times 12 feet is what we have. Step 3 is to do our work then. In this case, a little bit of algebra. To get the base by itself, we will undo multiplication by dividing both sides by 12. So step 3 gets us down to our answer then. If we divide both sides by 12, 168 divided by 12 is 14, is equal to B. Now think about what B is there. B is the base length. So our unit on this one would be feet, because it is a length. And if we were showing our units throughout the problem, we would have the square feet that would get canceled out by the 12 feet, and you'd be left with just feet. But in any case, you know that the base is a length, so it would not make sense to say 14 square feet if you're referring to a length, just 14 feet is our answer. And finally, example 4. Similar to the last problem, you have a rectangle. So we have area is equal to base times height. You know the area is 60 square centimeters. You know the base is 4, and you do not know the height. So 60 is equal to 4 times h. Step 3, again, is to do the algebraic steps in between. So we're going to divide both sides by 4. A little mistake here, let's erase that. So divide both sides by 4. And 60 divided by 4 would be 15. So 15 is the height. And looking at our units here, we are using centimeters. So 15 centimeters is the height. And so our answer is 15 centimeters.